All right, Erin, we're back. So same picture of notes. Now I want to look at this exact same problem, just how do you use a logarithm? So what the heck is a logarithm? How does it work? So first, I'm going to ask you to write out a chart. Let's put a little squiggle in between our notes. And I'm going to give you a chart of logarithms. So logarithms are abbreviated with log. I'm going to put a little 2 here and a 1 here. So it's almost like there's a subscript and then a regular number. I'm going to tell you that equals 0. And now I'm going to give you another subscript. Log a little 2 of 2 is equal to 1. Log little 2 of 3 is equal to 1.58. Log little 2 of 4 is equal to 2. Log little 2 of 5 is equal to 2.32. Log little 2 of 6 is equal to 2.58. Log little 2 of 7 is equal to 2.8. Oops. Log little 2 of 7 is equal to 2.8. We'll give it a 0 just because why not? And last one, log little 2 of 8 is equal to 3. So I'm going to ask you individually, you're going to hit pause, but not, hold on. I want you to examine this table that I gave to you and come up with a concept that you think is what a logarithm does. Like what is this function doing? See if you see any relationships between the numbers. So hit pause. I'm going to tell you what the answer is in a moment. Okay. So did you see this? 2 to the first power is equal to the number 2. 2 to the second power is equal to the number 4. 2 to the third power is equal to the number 8. This is interesting. 2 to the 0 power, you know that, right? 2 to the 0 power is equal to 1. Anything to the 0 power is the number 1. What a logarithm does is it actually fills in the blank. What happens between an exponent of 1 and an exponent of 2? Remember those fractional exponents? 2 to the 1.58th power is actually equal to about 3. Not exactly, but about. 2 to the 2.32 power is equal to about 5. 2 to the 5.8 is equal to 6. So a logarithm is going to solve for an exponent. So a logarithm is a function that solves for an exponent. And it can be very powerful. If I said to you, hey Erin, could you tell me what 2 to what power is equal to, I don't know, 27? You'd say, Miss Crisco, 2 to a power never equals 27, right? 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32. Nothing's actually equal to 27. But there is a fractional value that will come really close to the number 27. And we could see it graphically, but I want to look at it in terms of a logarithm. So a logarithm is just like a square root exists on your calculator. A logarithm is going to solve for your exponent. You just need to rewrite this into logarithm form. And the way a logarithmic form is you tell the log what the base is. I'm telling you, log, hey, I want to know 2 to what power is equal to 27. That's almost just like a square root. It kind of has that same idea. You're telling it the base and what you wanted to evaluate. Okay, how do you do it? You need a calculator, right? So if you can, on your computer, and I'll show you how to do it on your calculator too, but type in Google, get into a Google page, and I want you to type in logarithm calculator. So you're not gonna use this guy. Scroll down and look for where it says Log X Calculator Rapid Tables. So hopefully you see that one. It's Rapid Tables Calculator. I'm gonna click on that. And notice how it gives you this log with a little subscript and then your value. So I'm typing in log little 2 of 27. And I'm going to hit calculate. 4.7. That's what it's giving me out, 4.75. Okay, so this is telling me that my x value is 4.75. So it stands to say that if I did 2 to the 4.75 power, I should get approximately 27, should I not? All right, let's check it out. I'm gonna go down to here, anti-logarithm calculator, so really just exponential calculator. 2 to the 4.75, and I wanna hit calculate. Look at that. 26.9. And the more decimals I include, the better approximation I'm going to get to log of 27. Now the deal is, if there's not a exact value to a logarithm, so if you're like getting out an approximation, just like a square root, there's no exact value unless it's a perfect square. It's identical to that concept. Like, the square root of 7 is not a perfect square, so we're not going to get out an exact value. We have to approximate it. But there's certain logarithms that do give us exact values. Look, when like this base number and the bigger number, when those values are powers of one another, that's when you get out an exact value. Otherwise, they're approximations. Is that okay? All right, so I want to evaluate a couple of logarithms with you, but I think that's enough for this video.